Hi, welcome to my YouTube channel. My name is Dave. Today I'm going to show you how to solve linear equation of the third order using C#. What we are going to do is we are going to use object-oriented method to solve it. If you want to know how to solve it using non-object oriented method, you can click on the link below and watch that my previous tutorial on this same program. So first of all, what we are going to do is to show how simple it is when you have created your program in object-oriented programming form, that the user interface will be so it will be so easy and simple, because you have hidden some areas that will make the code so difficult to understand. That method is called encapsulation. I'm going to show all that to you as we go on. So what we are going to do is to create a class. I'm going to right click on the name of this program, which is a linear equations. When I right click, you will see add. Then hovering on add, there is this window that will show list of items. Under this list of items, click on class. Then you have a class with a default name, so we can change the name to any of the names that we need. For example, in my case, I call my class Determinants. Then you click on add. So our class is created. Creating a class in object-oriented programming has 4 steps. The first step is declare the variables. The second step is create a constructor. The third step, create the properties. And the fourth step is creating methods. So right now we have done the first step, which is creating all the variables we are going to use in this program. Look at the list of variables. We have x11, x12, x13, x21, x22, x23, x31. All these are the variables we are going to use, and we also have constant 1, constant 2, constant 3. Now these constant 1, 2 and 3 are the constant used in the equation. If you have linear equation, for example, if you have x1 minus x2 plus x3 equal to 5, that whole number after the 5 is the constant we are talking about. And if you want to know more about the presentation and want to understand more about the equation, there is a link below that will link you to my previous video where I made a profound illustration that you'll be able to understand very well. But it is on non-object oriented programming, and you'll be able to apply it in object-oriented programming as I'm doing it here. So we also declare the variables for the determinants. We have that constants, which is determinant 0. We have that root 1, which will represent determinant x1, and that root 2 will also represent determinant x2, and so on. Alright, we have created the variables needed for the placeholders, also created variables for the constants. Now the third and the fourth lines of variables, they are the determinants and also the roots. Take note that each of the variables in object-oriented programming, we have to make them private. Why are we making them private? So that users will not have access to your variables, thereby hacking your program. So the next step we are going to do is to create the constructor. Creating a constructor on your class, what you do, go to your keyboard and press Ctrl, then double press the tab button. So the next step we are going to do is to create all the properties for each of these variables that we are going to use in the program. Now I created a property for the x11. How do we create a property in a class? You type on your public, you hide double. You can decide to change the name, or you can capitalize the x and make it x11 as well, in order to recognize that is this variable. Then you put your curly brackets. It's just like, property is just like a method, but it is different depending on the arrangement. So you have your curly bracket in it, you have get and set method in it. So what get does is, get is able to give the value of your variable to the user, and set gets the value of the variable from the user to the program. So having done this, we are going to create properties for each of the variable except the third and the fourth variables that we are going to use, because the third and the fourth variables, we are going to get the values of these variables. In this case, the user is not inputting values. So right now we have created the values for the variables of the placeholders, which is x11, x12, x13, x21 till x33. We also created property for constants 1, constant 2, and constant 3. Once again, I repeat, if you don't understand the meaning of placeholders, the meaning of constants, please click on the link below and watch my previous video where I use a lot of illustrations to clarify. Now we are going to create the method of this class. Method is like the action of a class. So how do we create method? The first method we have created here is a method that will take the inputs of equation 1. Each method is created to do a particular action. For a method to be professional, it has to do one particular action in the program. So it can be used in different places because it has a particular action. But if we have many actions in a particular method, when you want to reuse it, it means all the actions in the method will still have to be implemented in that particular part. That's why method standing alone with one action is professional in programs. So right now we have created a method for equation 1. How do we create this method? The first statement is trying to lead the user on what to do. For example, we have the coefficients of the variables and constant for the equation 1. Then the next step, you see, insert the coefficient for the first variable. Now, when we have done this, outputted this with console.writeLine to output the statement that we need. Then we have to take the input of the user into this private variable, which is x11. We did the same thing for x12 and also x13. Then finally, we also did the same process and also trapped the input for the constant. We are going to do the same thing to equation 2, also to equation 3. So right now, we have done the same thing for equation 2 and equation 3. So in order to understand this, I'm going to show you nonlinear equation of the third order. So this is an example of an equation. So we have x1 minus x2 minus x3 equal to minus 3. This 3 is the constant. Then this x1, x2, and x3 are the variables, and they can be represented by placeholders. So having created a method that will receive the values of all the variables and also the constants, the next we are going to solve for the determinants. To solve the determinants, I created a method here called solve determinants. Now this method is only solving one determinant. So having declared this method, you have the public. Method can be private, it can also be protected. What I did here is I used this variable which we declared earlier as the determinant of the constant, and I used the formula of determinants. For you to understand this formula, you can watch my previous video. This is the expression of the formula. What I did, I returned this dead constant, which we are going to use for the next calculation, which we are going to use for later calculations. This determinant is like the dead zero that is normally used in calculations in mathematics. So we are going to also calculate the determinants for root 1, root 2, and root 3. Then we will find our roots. So I'm going to create the same method for each of the roots and using their particular formulas. So right now, I have created a public method for root 1, and it is called solve det root 1. This is it. So right now, I've created methods for det root 1, det root 2, and det root 3. When you go to my previous video, you will see the formula and you understand it better. In all these calculations, what I did, I returned det root 1. Sorry, this is supposed to be det root 1, not root 1. I'm going to copy and paste here. Yeah, so this depth root 1 is going to be what we are going to use for the next calculation. So we also did the same pattern using the formula for depth root 2 and also depth root 3 and returned the variables. So the next method we are going to create is a method to solve for the roots. So solving for the roots, we use the variable of root 1. So solving for the root, we create a method, a void method. The reason why we said void, because we are not going to return any variable. What I did, I created a void method and I call it solve the roots. I used this variable which I declared earlier for the roots, which is called root 1. And what I did is the return value of depth root 1, which is what you see here, depth root 1. I now use it and divide it by the depth constant, which we return here. So I also did the same to find for the root 2, which I used depth root 2 divided by depth constant. Root 3 equal to depth root 3 divided by depth constant. Then I will get my result. In order for you to... So right now we have created a program that is able to solve the determinants and is also able to solve the roots that we are looking for. It's like our program is almost complete. If we run this program, we will not be able to see anything except the instructions, except the method that we created to receive variables from the user. The method we created in this take input equation 1, take input equation 2, and take input equation 3. These are the things that we will see, but the calculational parts and the results we will not be able to see. But the results and also the determinants we will not be able to see. The result, which I mean the roots, the root 1, 2, and 3, that the most the thing that we're supposed to, the result we are expecting, we will not be able to see. So in order to see these results, we are going to create a method that will show our answers. In order to show our answers, I created a void method called show the roots. This method will show the roots. What I did, I wrote console.writeLine. Of course, this console.writeLine, these two console.writelines are just to give a space of 2 lines. Then the next is to output the variables. Of course, these statements are all string, and the curly bracket 0, curly bracket 1, curly bracket 2 are placeholders. Then these placeholders, each of these variables, the roots that I'm wrote here from the result of my calculation in this solve the roots method, this result, when I place them here, they will be placed in the string in according to the numbers and according to the arrangements here. So this method will show our answers. So let us run our program by going to the program, by coming to the program and creating instance of this class determinants that we have created, and also run it to see the results, to see what we are going to have. So first of all, we are going to create an instance of the class. We have determinants, determine equal to new determinants. This is the instance of the class. So right now we have created the instance of the class. So what we are going to do right now is to first of all call the method that will ask the user to input values. So doing that, we copy and paste this instance we created and put your dots. It will bring out options. Now the options we are looking for is to take input equation 1. So clicking on it, and if you put your open and bracket close, then you put your semicolon. This is how we call the function we created in the previous class. Now this is the instance of that function or method. So we are going to also call the rest of the method that will be able to receive input from the user. So these 3 methods are going to receive values from the user. So next we are going to call the function that solve the input received from the user. So we have called solve determinant, solve the root 1, solve that root 2, solve that root 3, and also solve the roots. Now, having called these functions, we are going to call the function that will show us the answer. So this is the function that is going to show us the answer. Now let us run our program and see what we have. Running your program, I'll click on. So the command line has shown up. So the first thing is we are going to insert the coefficient of first variable. We can use any equation to solve this. For example, these are linear equations of the third order. So what we are going to do, we can choose any equation here. If we choose number 5 to solve, then let's input the coefficients of each of the variable as requested. So as we have seen here, the coefficient of the first variable is -2, and the coefficient of the first variable is -2. The coefficient of the first variable in the first equation is -2. The coefficient of the second variable in the first equation is 3. And the coefficient of the third variable in the first equation is -2. Of course, the constant is 4. So we are going to write down all the coefficients of the variables and also the constant. So we are going to input all the coefficients of the variables and also the constants. Then we will see our results. So we have inserted the coefficients of all the variables and their constants in the equation. Then these are the results, which is the roots. We have root 1, root 2, and then root 3. So it is super simple using this program to solve every kinds of problems concerning linear equation of third order. But sometimes people will not be satisfied with these results. They would like to see what the equation look like and also the determinants that divided to give us the roots. So we are going to create two methods. So doing so, I'm going to turn off my command line. So here in the class, I'm going to create the two methods. So here we have, I first of all created a method that will show all the determinants. And secondly, I created a method that will show the equation. So we are going to call this method in the program. So right now I've called the methods that will show the equation and also show all determinants. And what I did now, I created two line space. So there will be space in between for it to be clear for viewers to see, for it to be cleared for viewers of the codes to see. So now let's run our code and see the results. So the program is running. Let me go ahead and put the coefficients of all the variables as we did previously. So having inserted all the coefficients of the variables and their constants, you see, we can now see the equation that we solved. You have your -2x1, 3x1 and 3x2 minus 2x3. Definitely when there is no sign in front of this, for example this 3x2, you know that is plus sign that is there. And we have 1x1, 1x2, and so on. So this is the equation. Then the determinants we divided in order to calculate for the root in accordance to the principle of linear equation of the third order. In accordance to the principle of linear equation of the third order, these are the determinants. For example, in root 1, where root 1 is equal to -25, dividing these determinants for root 1 by this determinant, which is -25 divided by 25, the result is -1. Then if you divide this 50 of the if you divide the determinant for root 2, which is 50, by this determinant, if you divide 25 by the determinant of the root 2, you have +2. Then also if you did the same thing for the determinants for root 3, you have -4. So this is it. You can use it to solve any problem concerning linear equation of the third order. If you find this tutorial helpful to you, please click on the like button. If you would like me to do any other video on any other topic in mathematics or in physics, or just name any topic, then I will do it in the next video. Then if you like to see more of my videos, please subscribe on my channel. Alright, so you can take a look at the code that we created from the starting to finish. This is the code that we called. You can also go back to the determinant class, the declaration of all the variables, the constructor that we created was able to help us to create instance of this class. Then we also have all the properties we created here. Then we have the method. We have the method for the inputs, the method for this input as well of equation 1, the method of equation 2, so you can take a look at the code from the beginning to the end.